Okay, so in the previous video, we already completed the errors part for normal distribution. So for today, we'll move on to binomial distribution, and we want to calculate the errors in this distribution. Right. So mainly we'll focus on binomial, and then we are still focused in the errors part, type 1 and type 2 error. Alright, so but for binomial distribution, it is a little bit special, a little bit different from normal because binomial is discrete random variable. Alright. Okay, so what you need to know is when we carry out a test that involves the discrete variable, right? The significance level, the alpha, given in the question, right? We call it as nominal significance of the test. If let's say you want to look into detail, right? So this is the nominal significance of the test. All right. And then for this part, you need to know also in binomial distribution, the type 1 error is actually equals to actual significance level. Alright, so please make sure that you remember this word, okay, and also this name. So type 1 error is actually, the probability for type 1 error is actually the actual significance level of the test. So the alpha that usually we get it in the question, right? The question straight away give you one. That one is nominal significance level. So for discrete random variable in binomial and Poisson, there's a small difference. So you need to know about these two words here. So this is mainly for discrete random variable. All right. Okay. So now you need to know that the actual significance level is always smaller or equals to nominal significance level. So again, nominal significance level is alpha. Then usually the type 1 error that you calculate out is smaller or equals to the alpha. So maybe some of you will ask, in the previous video we learned, right? Okay, for type 1 error, the probability for type 1 error, in the previous video, in normal distribution, what we learned is it is equals to alpha. So this is true, but it is only for the continuous random variable. All right, which is the normal distribution. Okay, so for discrete random variable or binomial and Poisson distribution, you need to remember this new result, which means that the actual significance or the type 1 error probability is always smaller or equals to alpha. All right, so this is important. So please make sure you remember it. Right, so if we proceed further, okay, same like normal distribution. If let's say the rejection region is not given in the question, then you need to find out the rejection region before you can calculate the type 1 and type 2 error. Alright, so to find the rejection region according to the alpha, this is the steps. This is a summary, I can say it is a summary, but it will not show you how you actually get the rejection region. So I will show it to you, okay, in the next video. Alright, in step by step to explain how we actually get the rejection region. It is not hard, but it is quite hard for us to describe it in the notes. Right, so we will discuss in the next video for this rejection region part. So to find out the rejection region, this is a summary, or this is a reference for you how to start. Alright, so the details step you still need to refer to the video, okay, in our discussion later. Okay, alright, so continue further. Similar like what we have, okay, in the binomial distribution, when you are having a large sample for binomial distribution, you also need to find out the rejection region by using the normal approximation, because when the sample size is large, then you can change binomial become normal, right? So during that time, you need to calculate the rejection region by using the normal approximation, but of course, you still need to consider the continuity correction. So this we will discuss in the next two videos. Okay, next videos. Okay, how are we going to find the rejection region and calculate the type 1 and type 2 error when we change a binomial become normal? All right. So for this whole part here, the errors for binomial distribution, we are going to have 3 videos. Right. The first one is this. Okay. The second one is to discuss how we find out the rejection region by using binomial, and the third video under this part will be the last one. When we change binomial become normal, how are we going to find out the continuity correction? How are you going to find out the rejection region and also the type 1 and type 2 error probability? Okay, so for now, this is something very important. Make sure that you know what is the meaning of actual significance level and what is the meaning of nominal significance of the test. All right, so there's a relationship here. The actual significance level is smaller or equals to the alpha that usually given in the question. Okay, right, so we will start discuss some example here, okay, to see how are we going to attempt all the questions related to this. All right, so maybe we can have a look. For example 33. Right, so if you read the question, you will see that there's a supplier of orchid seeds claim that the germination rate is 0.95. Then there's a purchaser of the seeds suspect that the rate should be lower. So I think lower is a very obvious keyword to tell you about the alternative hypothesis. Okay, so in order to test this claim, the purchase plants 20 seeds in similar condition, count the number x which germinate. He rejects the claim if x is smaller equals to 17. Alright, so first they want you to formulate a suitable null and alternative hypothesis to test the seed supplier's claim. Alright, so they only want you to write out the null and alternative hypothesis. So when you read the question, I think very obvious that you already get the keyword which is lower. So the lower rate means that the P should be less than what they claim, which is 0.95. Alright, so this is P equals to 0.95. Okay, so you should know that since we are going to test about the probability proportion, population proportion, so the distribution that we are using should be binomial distribution, and then the n should be 20, 26 with 0.95. Okay, this is something that I write out extra so that I can refer to it later. But the answer for part 1 is this one, the null and alternative hypothesis. Okay, then for part number 2, they want you to calculate the probability of type 1 error. Okay, so to calculate the probability of type 1 error, so recall back what is the definition for type 1 error. So the definition for type 1 error is you reject the null hypothesis when the null hypothesis is true. Okay, so for the reject null hypothesis part, you need rejection region. Okay, so where can you get the rejection region? If you read this question again, all right, so I want you to have a look for this sentence here. He rejects the claim if x is smaller equals to 17. He rejects the claim. So what is the claim here? So the claim here means supplier claims that is equals to 0.95, right? So this claim here means that the rate is 0.95. So the word reject, the phrase reject the claim means what? Means that it is reject the null hypothesis. Okay, when will he reject the null hypothesis? When x smaller equals to 17. Okay, so if x equals to 17, smaller equals to 17, and you reject the null hypothesis, it also means that this is your rejection region. Alright, so although the question didn't tell you very clearly, but you should try to figure out that this is actually the rejection region. Okay, so we are going to continue to put it in. So reject null hypothesis means you need to put in the rejection region, which is x smaller equals to 17. Given that null hypothesis is true, that means you are using p equals to 0.95. Alright, so just want to remind you that when you are having the p equals to 0.95, that means you are using binomial distribution, n is 20, then the p is 0.95. So you use binomial formula to calculate the probability. So x smaller equals to 17. The step is very long because you need to include the calculation start from 0. X equals to 0, x equals to 1 until 17. So what I do here is I will minus. So I take 1 minus 18. 18, wait, so this one should be 0.05. Okay, then 19. And also 20. So you take 1 minus x equals to 18, 19, then 20. Alright, so by just pressing the calculator, you will get the answer for type 1 error, 0.0755. Alright, so this is what we have as the type 1 error. So before you calculate the type 1 error, of course, you need to figure out what is the rejection region first. So for this example, they already give you the rejection region in the question. So you have to try to analyze and identify it. Okay, so this is actually the rejection region which is given in the question. Okay, then continue further. So you will see that when they give you the rejection region, right? So your step actually quite simple. You straight away apply it in the formula and then you just calculate only. Right, quite easy, quite straightforward. Okay, so now we continue to part number C. They want you to calculate the type 2 error if the probability that the seed germinate in fact is 0.8. Okay, so let us start type 2 error. Okay, wait. Alright, so I will start with type 2 error here. So part C. I want to calculate the probability for type 2 error. Okay, so what is the definition for type 2 error? It should be accept the null hypothesis when the null hypothesis is false. Right? Then what is the formula that you need to put in for accept null hypothesis? So accept null hypothesis means that you need to put in acceptance region. To put in the acceptance region, since you already know this is the rejection region, so acceptance region will be the opposite side of this. So the acceptance region should be x greater than 17, no equal sign. Or you can write it out as x greater equals to 18, also can. These two are the same. Alright, so for me, I will just write it out as x greater than 17. And when the null hypothesis is false, they will give you a new value for P. So in this question, you see that they give you a new value for P, which is 0.80. Okay, so what does it mean? It means that for now, when you want to calculate the probability, it is X, it is still binomial, N is still the same, which is 20, but the P now is 0.80. It is no longer 0.95. Okay, because the null hypothesis is false, so you should have another value of the P. Okay, so they give you which is 0.8. Alright, so I will continue with the calculation. So x greater than 17, you cannot, you can start from 18, right? 17 is not included, so you can start from 18, which means that your formula for binomial should be 20C18, 0.8 power 18, 0.2 power 2. Okay, then you continue further until 20, so 20C19, then 20C20. Okay, then just press calculator and the final answer that you get should be 0.206. This is what we have. Okay, so you can see that this example mainly we focus on how to calculate the type 1 and type 2 error in binomial distribution, and the rejection region is already given. So you will see that when we calculate all the probability here, we are using the binomial formula, right? Because it belongs to binomial distribution. Okay, so this is what we have for example 33. Okay, then now we continue further to example 34. All right, okay, you can read the question first. So for this question, they already tell you very clearly that I take a sample. Okay, a random observation is taken from a binomial distribution and they want to test the null hypothesis against the alternative hypothesis. So this is your alternative hypothesis. They already write it out for you. Okay, then here they said the critical region is chosen to be x greater equals to 19. So this question is very straightforward because they already tell you that this is your rejection region. So critical region will be the rejection region. Okay, so that means it's very clear. They give you the rejection region, so you can use this rejection region to do all your calculation later. Right. First, okay, part A. What is the significance level of the test? Okay, so significance level of the test means the nominal significance, which is the alpha. All right. So for this binomial distribution, they didn't give you the alpha, right? You have to calculate it on your own. So to calculate it on your own, to get the significance level, you still need to find out the type 1 error. So please remember this. Alright, so they ask you to calculate the significance level. You still need to calculate the type 1 error before you can find out the significance level. Okay, so what is the type 1 error here? Alright, so the same. You have to put in a definition first. So type 1 error means reject the null hypothesis when the null hypothesis is true. Okay, then for the reject null hypothesis part, you need to put in the rejection region. So I'm having x greater equals to 19, given that the p is equals to 0.8, which is also given in the question itself also. Then usually for me, I will just write out the distribution that I use. So it is actually binomial distributed. Sample size is 20, p is 0.8. And I want to continue to calculate the type 1 error here. So greater equals to 19 means 19 and 20. Therefore, I'm having 20C 19, 0.8 power 19, then plus 20C 20. Okay, then from here you will get the 0.0692. Alright. So to find out, okay, this is your type 1 error. So to find out the significance level, you just recall back the result that we learned just now. Okay, since we know that the probability of type 1 error, okay, should be smaller or equals to significance level. This is a theory that we learned just now, right? A fact that we learned just now when we just started this video. All right, so now your type 1 error is something that you calculate just now, which is 0.0692. Should be smaller or equals to the significance level. So that means on this significance level should be more than or equals to 0.0692, right? Okay, so when you write out the result, you can write out like this. So the significance level okay, can be equals to 6.92%. If let's say it is equals to 0.0692, so it will become 6.92%. And then usually for significance level, usually they will actually want you to have a whole number, like 5%, 10%, 8%, something like this. So since they said 6.92 and it can be more than 6.92, you can also round it up, become 7. All right, this will be your answer. Okay, if they want it to be a round whole number, then you can write it as 7 because significance level should be equals to or more than 6.92%. So you can change it become 7 if you want. Okay, but for me, myself, right, usually I will write out both That means I will write out the smallest significance level, which is 6.92, and then I will also round it off to 7% if this number itself is very close to the next whole number. Like 6.92 is very close to 7, right? So I will write out the 7 as a whole number answer for significance level. Usually I will write out 2. Okay, so if let's say you're having 6.12%, so I'll just keep it at 6.12 lah. I will not round it up to 7 unless the question stated that they want a whole number. Then you round it up. Understand what I said now? So for this part, some students will feel confusing, like significance level can be equals to type 1 error or not? Can. So the smallest value for significance level will be type 1 error. But in the question, if they want a whole number, you can round it off to the next whole number. Right? So this is what you have for significance level. Yeah, so both you need to write it out. Then for part number 2, they are asking you what is the probability for making a type 1 error. So this one you already carry out the calculation in part number A, right? So your type 1 error, you just write out the answer 0.0692. Okay, because it should be the same. This is the value that you get from type 1 error, right? So your type 1 error should be 0.0692. Okay. Then continue for part number C. They want you to calculate the probability of making a type 2 error. Alright, so now to calculate the probability for type 2 error, what is the definition for type 2 error? You accept the null hypothesis, okay, when the null hypothesis is false. Alright, then I told you already, right? Accept null hypothesis means that you need to put in the acceptance region, which is the opposite from rejection region. So it should be smaller than 19. Okay, then P, what is the new value of P given when the null hypothesis is false? So 0.85. Alright, then you try to calculate this part of the answer lah. Okay, so just a reminder, for this you are actually using binomial distribution 20 and then 0.85. Okay, so please try to complete the step here, how to calculate the probability for x smaller than 19. Okay, in a binomial distribution, I won't show you. Okay, final answer that you get should be 0.824. Try and see whether you can get this answer or not. Should be no problem now because it is quite straightforward one. They just ask you to use the binomial formula to calculate the probability. So this will be the probability for type 2 error. Okay, so from this video, you see that, for example, 33 and 34, right? They already give you the rejection region in the question itself. So you just need to use the information from the question to calculate the type 1 and type 2 error, which is not hard and quite straightforward. Alright, so in the next video, we are going to discuss the examples that they didn't provide you the critical region or maybe the rejection region, and we need to find out on our own. So we'll discuss all this in the next video.